In today's topic, we'll be talking about trigonometry in right angle triangles. So there are three trigonometrical ratios. First one is sine, S-I-N, short form for S-I-N-E, sine. Next one will be cosine, C-O-S, short form for C-O-S-I-N-E. And the next one will be tangent, T-A-N, short form for T-A-N-G-E-N-T. So these three will be the ratios for trigonometry. So let's look at the first one is called sine. This is called Peter. Peter is angle. So sine Peter. So in right angle triangles, the Peter will be an acute angle. So acute angle is between 0 and 90 degrees, exclusive of 0 and 90 degrees. So sine Peter is equals to opposite over hypotenuse. So that's why you have to learn Pythagoras theorem first. So opposite of the triangle over the hypotenuse, which is the longer side of the triangle. So cosine Peter is equals to adjacent over hypotenuse. Adjacent side is where it's closer to the angle that you are looking at. So adjacent over hypotenuse is to find cosine Peter. And lastly, we have tangent Peter is equals to opposite over adjacent. So opposite of the triangle over adjacent of the triangle is to find tangent Peter. So tangent Peter is also equals to sine Peter over cosine Peter. So for example, you are looking at tangent 20 degrees is equals to sine 20 degrees over cosine 20 degrees. So that's one of the example. So now let's look at special angles. We have here 30 degrees, 45 degrees, 60 degrees, 120 degrees, 135 degrees, as well as 150 degrees. So let's look at these two special triangles. Let's look at the first one right now. This is an equilateral triangle, 60 degrees, 60 degrees, 60 degrees. So let's do a bisect here. So cut into half. So this will be a right angle triangle. So this is 90 degrees. This is still 60 degrees, whereas this will be 30 degrees. Okay, so you have learned your Pythagoras theorem. So for example, let's have this as side of 2 cm each. So when I bisect this will be 1 cm, whereas this is 2 cm, which is the longer side of the triangle. So you have to find this side length. So using Pythagoras theorem, you have to use a square equals to, okay, I'm looking at this a square. Okay, I want to find a. So a square equals to c square minus b square. Okay, so c is the longest one. So 2 square is 4. 4 minus 1 square is 1. So 4 minus 1 will give you 3. So square root 3 will be the a. So this is the length. So it's square root 3. So by using Pythagoras theorem, you have found this unknown length. So this is one of the special triangle that you have to use to find for these angles. Okay, so let's look at how to apply it then right now, since you already known or the length of this triangle. So sine theta, remember, is opposite over hypotenuse. So how do we apply it? Let's look at it. I would like to find 30 degrees. So where do I find my 30 degrees? 30 degrees is over here. Okay, 30 degrees is over here. So let's look at it. Opposite over hypotenuse. So opposite will be 1 over hypotenuse is 2. So sine 30 degrees is equals to half. Okay, sine 30 degrees is equals to half. So using cosine theta, okay, cosine theta is here. 30 degrees is my theta. So adjacent, okay, let's look at 30 degrees is over here. The nearest will be this. It's not this, huh? This is hypotenuse. It won't change. So this is the adjacent. So it's square root 3 over 2. Hypotenuse is 2. Okay. So the last one will be tangent theta is equals to opposite over adjacent. So looking back at this triangle again, okay, tangent 30 degrees is over here. So opposite would be opposite 1 over adjacent, square root 3. Okay. Previously you also learned that tangent theta is equals to sine theta over cosine theta. So you can use half divide by square root 3 over 2. So you will get 1 over square root 3 as well. Okay, let's look at the next one where sine 60 degrees. Okay, sine 60 degrees. So looking back at the same triangle again here. So 60 degrees is over here. So apply the same rule. So O over H. Okay, short form, O over H. So O will be square root 3 over 2. That's to find sine 60 degrees. Cosine 60 degrees will be this side. Is adjacent A over H. Adjacent over hypotenuse. So cosine 60, A will be 1 over 2, which is half. And lastly, tangent 60 degrees is equals to O, which is square root 3 over 1. Okay, square root 3 over 1. So lastly, we have to find 45 degrees is another special angle. Okay, so we need to use another triangle. So this is equilateral triangle, this is isosceles right angle triangle to find 45 degrees. So 45, this will be 45 as well. So this is 90 degrees. Each of the side is 1. So the hypotenuse will be a square plus b square equals to c square. So 1 square plus 1 square equals to 2. So square root 2 will be the hypotenuse. So sine 45 degrees equals to opposite over hypotenuse. Opposite sine 45, any angle will be 45 for this. So opposite is 1 over square root 2. Cosine 45, A over H. Cosine 45. So nearest will be this 1 over square root 2 as well. So tangent 45 degrees equals to, you can use sine divided by cosine. So you get same one, divide will be 1 over 1 or 1. Or tangent 45 degrees is equals to O over A. So tangent 45 is O over A, 1 over 1. So this is the end of the example for special angles. We have not touched 120 degrees, 135 degrees, 150 degrees. That will be on the next video. So look out for it.